Alright, so today I'm going to do a video lesson on section 9.2, which is multiplying polynomials. So we've done addition and subtraction of polynomials before this, so now we're doing multiplication of polynomials. And here I have an example. I have a monomial, 2x to the third power, and it's being multiplied by this polynomial over here. It's a trinomial to be specific. X squared plus 5x minus 4. This is a very simple case, and technically you only have one polynomial here, but the way you would work this problem out would be just like any other multiplication into a parenthesis. You would distribute whatever's outside of the parenthesis to every single member inside. So and then you would just carry out your multiplication. Fairly simple. And we've done problems where you multiply a pair of bases that are the same, and what do you do with the exponents? You add them up. So we've done this before, so once you kind of configure the problem this way, the work itself should be fairly simple, or at least we've done problems like this separately before. So it turns into 2x to the third times x squared, which is just 2x to the fifth, plus 2x to the third times a positive 5x, which is a 10x to the fourth, and then 2x to the third times a negative 4, which is a negative 8x to the third. So that's just a very simple case here. And typically we won't deal with problems quite this simple. What we are going to concentrate most on is multiplying a pair of polynomials. So here we just had a monomial times a polynomial. So now I want to show you how to work out problems that have two polynomials being multiplied against each other. So for example, I'll give you this particular case. X minus 2 times x plus 3. Two very simple binomials. One binomial, two binomials. Both of them are first degree binomials, really about as simple as polynomials get. And they're being multiplied against each other. Well, there are two ways of solving this particular problem. I'm going to teach you both ways. The first way is known as the FOIL method. So what the FOIL method, it's an acronym that stands for first, outer, inner, last. So this stands for first, outer, inner, and then last. This essentially tells you which order you should be multiplying your monomials. So the F stands for first, and that tells you should first multiply your first monomials of each polynomial. Well, that's the first monomial of this polynomial, that's the first monomial of this polynomial. So you want to multiply this one with this together. So that is step one, which gives us our x times x, and that's x squared. The second step is to multiply our outer monomials in each polynomial. Well, that's outer, and that's outer, the x and the 3. So you multiply these two, and x times 3, that's just positive 3x. Then we get to the inner part, and the inner part tells us to multiply the two inner monomials. Well, these two are the inner ones. The negative 2 and the x, remember, it's not just the 2, it's a negative 2, and that gives us a negative 2x. And then the last tells us to multiply the last monomial in each polynomial, and that's last and that's last. So that's going to be the negative 2 times the positive 3, which gives us the negative 6. And we're almost finished here. Now this is almost an answer, except your answer has to be fully simplified. And here we have something that's not fully simplified. Specifically, we have two first-degree monomials right over here that you can simplify out. They're both first degree. It's 3x minus 2x. So the final answer will be x squared plus x minus 6. So that was the FOIL method. And the FOIL method is excellent to use with any pairing of binomials. So anytime you're multiplying two binomials, the FOIL method is probably the best way to approach the particular problem. But I'm going to show you another method. Here I have another pair of binomials being multiplied against each other, and you could definitely use the FOIL method here if you wanted to multiply the first, then the outers, then the inners, and then the last, and that would give you the answer. But I'm going to show you a different method. I'm going to use the table method or the square method for this particular problem. To save time, I'm going to pause this and draw the square, and magically a square appears. So this is how you solve this type of problem using the table method. You'll take your first polynomial, the one on the left, the 2y minus 4, and you'll write it out on the left side of the square. The highest degree monomial goes first. That would be the 2y, it's first degree. The lowest degree monomial goes below it, and that's our 0 degree, negative 4. And not just a 4, remember, it's a negative 4. Then you write your second polynomial on the top. Again, the highest degree monomial goes first. That would be our 3y squared because it's a second degree monomial. And the lowest degree monomial goes after it, and that's our 1, the 0 degree monomial. Once you have it set up like this, all that's left is to cross multiply the boxes. So you cross multiply this way, this way, this way, this way. And let's see what we get. So in the top left box we have 2y times 3y squared. That's going to give us 6y to the third power. In the top right box we have 2y times 1. Well, that's just 2y. In the bottom left box we have negative 4 times a positive 3y squared, which is a negative 12y squared. And in the bottom right box we have negative 4 times a 1, that's just negative 4. So once that's all done, you're going to go ahead and look to see if you have any degrees of monomials that are in common. So here I have third degree monomial, and it's the only one of its kind. Here I have a second degree monomial. It's the only one of its kind. Here I have a first degree monomial. It's the only one. And here I have a 0 degree monomial. And at this stage, if you had anything similar, you would have simplified the similar degree monomials before you move on to the next step. But I have nothing in common, so I'm going to move on to the next step. And the next step is write out the answer starting with the highest degree monomial, ending with the lowest degree monomial. So your answer is right away in standard form. So the highest degree monomial is the one in red, the 6y to the third, plus the negative 12y to the second, that's the second degree monomial, the one in the blue. Then the one in the green, our first degree monomial, plus 2y. And then lastly, minus 4, our 0 degree monomial. And that's the answer. Now, if you use the FOIL method, would you come up with the exact same answer? Yes, but this is just a different way of doing it. So now I'm going to show you how to deal with a problem that is a multiplication of something more than just two binomials. So here I have a multiplication of a pair, so a binomial and a trinomial. So instead of just being binomial and a binomial, we are multiplying a binomial and a trinomial. And I'm going to go with the table method first, because here I think the table method actually works a little bit better than the other. Actually, FOIL, exactly as I've shown you before, doesn't really work for this type of a problem. Table method works regardless of the size of the polynomials. You just have to modify your table. So we had a 4 by 4 before because we were multiplying a pair of binomials. Here we have a 2 by 3 because we're multiplying a binomial and a trinomial. So just like before, you write your first polynomial on the left, your second polynomial on the top. Again, highest degree monomials go first. And then you carry out your multiplication. And you kind of fill in the table as you go, one at a time. Then once you finish multiplying everything out, I already kind of did it out for you, you will find any difference in degrees and you will kind of isolate them. So I got my third degree monomial first. I highlighted it in red. It doesn't have a counterpart, so it's alone. So I'm going to write it out right over here because there's nothing else I can do to the third degree monomial. And then I look to see if I have any counterparts within the lower degrees. So I have a pair for the second degree. So I'm going to combine them. I have negative 4b squared and positive 18b squared, which gives me a positive 14b squared after I combine the two. I have a pair of the first degree monomials, negative 21b and a negative 24b. So I'm going to combine those two, which is going to give me a negative 45b. And then over here, I just have the 0 degree monomial all by itself again, so I'm just going to write it out. And this is the answer to that problem in standard form, all ready to go. So it's a pretty good method of working out a problem like this one. I can also do a similar problem in a different way. So I did binomial times a trinomial using the table method. I can use a method similar to the FOIL method, known as the clamshell method, to solve the problem out. I think for these types of problems the table method is better, but if you were to solve a problem like this, you would have to distribute the first polynomial into the second polynomial one at a time. So I'll start with the first monomial here, and I'll make sure that it's distributed to every single member of the second polynomial, and I'll do the same thing with the second polynomial, the second monomial, the first polynomial. I will distribute it evenly into the second polynomial. So kind of see it looks like a clamshell. And once I do this, I simply multiply across and I get 4x times 2x squared, which is 8x to the third. Then it's 4x times 5x, which is a positive 20x squared. And then 4x times a negative 1, which is a negative 4x. And then I'm done here, so I'm going to start distributing this. It's going to be negative 6x squared because it's negative 3 times 2x squared. Then negative 3 times 5x, that's negative 15x. Then negative 3 times negative 1, it's a positive 3. Then you find your common terms, so you look at for monomials with the same degrees and you can combine them. So I can combine the second degree monomials, I can combine the first degree monomials. The third degree and the 0 degree don't have counterparts, so there's nothing I can do there. The answer for that particular problem. It doesn't really matter for me which way you use, whatever method is more comfortable for you, but these are the two of the ways you can solve multiplication of polynomials.